Welcome back to Wes Explains Best. We're going to pick up where we left off in the geometry chapter on surface area and volume with 11.5 volume of pyramids and cones. Now, one thing I would do if you haven't done so already, watch a YouTube video that shows how volume of a pyramid relates to a cone. A pyramid relates to a rectangular prism and how a cone relates to a cylinder. Once you see that demonstration with pouring of water, it's going to make a lot more sense to you. So I'm going to kind of touch on that here, but I encourage you to watch that video. I'll try to link it in the description below so you guys can see that. But I'm going to go ahead and show a cylinder. I'm going to draw a cylinder here. I'm going to copy it. I'm going to paste. Okay, because I don't want to give you the formula without explaining how it's derived, okay? And then I'm going to draw, okay, so that's a cylinder. I'm going to rewind a second. We know the volume of cylinder based on the previous section is pi r squared h. That is the volume of a cone, or excuse me, a cylinder. A cylinder is essentially a type of prism, which any prism is going to be volume equals the area of the base times the height. That's any prism. So the area of the base of a cylinder is a circle, so it's pi r squared, and then we multiply the height. Okay, now what happens if we draw a cone with the same dimensions in terms of height and radius, but of course it's a cone? What happens? How does the volume relate? Well, we're also going to do something else before moving on to that question. Okay, I'm going to draw a pyramid the best that I can, a square pyramid. Okay, so let me draw the radius here just so you can get an idea. Radius and then height. Okay, don't want to be sloppy here. Okay, now I'm going to draw my pyramid, square pyramid, so I need to make sure all the sides have the same length. This is in the back. I should get a little eraser so you can see that this is heighting. Okay, and this one's hiding. This is in the back. Okay, close enough. All right, so this is a side. This is a side. And then, now we need to use the height. I know in the surface area, we've been using slant height for the pyramid, but now we need to be using the actual height, not the slant height anymore. Okay, so that's a pyramid. And what I really should have drawn first is I should have drawn my rectangular prism. Oops, I drew that too high. Let me erase this a little bit because that's got to go in the middle. Okay, so I'm drawing my rectangular prism, and a cone is just a part of that, a pyramid is just a part of that rectangular prism. It touches the top. That was supposed to be the middle. I hope you guys can pretend to visualize that. Maybe I can, but just bear with me here. Okay. So if I drew a solid shape here around this pyramid, okay, how do these volumes relate? Well, it turns out that these volumes, this volume over here corresponds to him, that these volumes have the same proportional relationship to their bigger shape. What do I mean by that? Well, the cone to its cylinder and the pyramid to its cube have the same relationship, and that is that they are 1/3 of the size. You could fit the volume of 3 pyramids inside a rectangular prism with the same side lengths and the same height. Okay, that's why if it's a little hard to believe, make sure you check out that video because they demonstrate how actually 3 cones fit inside its related cylinder and how 3 pyramids fit into its related cross-section, or how it's rectangular prism. Okay, so here's the volume of a pyramid, which is the area of the base times the height divided by 3, and then here's the volume of a cone, which is pi r squared divided by 3. It's very important that you understand that this could change depending on the pyramid. Now, if it's a rectangular or a perfect regular pyramid, it's going to be volume equals the side squared times the height divided by 3. But that's not most often the case, so I wouldn't encourage you to think of it that way. Take the area of the base, multiply it by the height. That's for any prism, and we divide by 3 for a pyramid. Cone, we take the cylinder formula, pi r squared, h divided by, and then we just divide that by 3, and that gives us our cone. Okay, so we have a couple problems here. Our first problem is a pyramid. So we have a pyramid, and we have some dimensions of this pyramid. Okay, so with this pyramid, we're given a couple pieces of information which we need to dissect. So we're given a side length, we call that S, we're given another side length, and we're given the slant height. Notice how it gives us the slant height and not the actual height. The actual height is in green here in the back. So you can kind of see that this right here is what we're really after. That's the height inside this pyramid. So it's in the center of this pyramid. This goes in the back like this, and this is in the exact center. So this would tell us how tall the Pyramid of Giza is. So find the volume of the Pyramid of Giza. Okay, now we need a couple pieces of information. One, we see that we can form a triangle. Let me erase this. We can form a triangle with the height and this slant height. So if we do that, we're going to have this third side right here. This is that triangle. So the slant height is essentially the hypotenuse of this right triangle. The height is the height that we're looking for, the leg of that triangle. And then this unit is half of 756.8 because that is half the square. So I'm going to get my calculator out. And I'm in a pinch, so I'm using a phone calculator, which is not ideal, but I think we'll be able to hang. 0.8 divided by 2 equals. So we get 378.4. Now, how do I find h? Well, I need to use Pythagorean theorem. So I'm going to take 612.32, square it, 612.32 times 612.32. Oh boy, I messed up. 612.32 times 612.32 equals. Okay, I get a big number. I'll show that in a second. This is going to be h squared. I know it's a different color, but I want to. Speed is the key here. 378.4 squared. Okay, so for this squared, I got 374935. I'm going to round it, 78. For my height, I don't know. That's what I'm looking for. And 378.4, I need to multiply that by itself. And I get plus 143,186.56. I need to subtract this from both sides, 143,186.56 minus 143,186.56, 374935.78 equals. Okay, what I get is I get 231,749.22. Okay, and that equals a squared. So finally what I need to do is I need to take the square root of that. So I need my phone calculator conveniently does not have a square root function, so I need to go to my friend Google, and I'm going to type this into Google, 749.22. Make sure you guys are always well equipped before beginning math problems. That is step number 1. Okay, and I get my answer, which is 481.4. And what is the units? I think this is feet. That's how tall the Pyramid of Giza is. Now, we need to use this to find our volume still. We're not done. So what we have to do is we have to apply our volume formula. Our volume formula is, let's use this orange. Volume equals the area of the base times the height divided by 3. Well, the area of our base, that's actually true for both pyramids and cones, but just we know that for cones, it's pi r squared for the area. Just heads up. Okay, so now we have our area of the base is going to be 756.8 squared, and then times our height, which is 481.4. Forgot the 1. And then we're going to divide that by 3. So I'm going to go ahead And I'm going to multiply this by 756.8 to the second power. And I get, this is a big pyramid we're talking about, 207, let's see, I don't know how many commas are in this yet, so I want to make an educated decision. Okay, so we have boom, boom. Okay, so this is humongous. This is 275 million cubic feet. So this pyramid is large. They could fit a lot of mummies in there. And that's how we do that. Okay, so it's very important that you make sure you find the information you need based on what it gives you, and then you proceed from there. This problem is going to be somewhat similar. Again, it doesn't give us our height. We're trying to find the volume of this cone, and we know the volume of a cone is pi r squared times the height divided by 3. We're given the slant height. So we're not given the actual height, which is what we're trying to find. So again, we're going to apply the same issue. We say 16, 4 squared equals 8 squared plus 2 squared. Whoops, you know what that means. Then we have 16 equals 8 squared plus 4. So we get 12 equals 8 squared. I'm going to leave this in radical form just because I'm sure you guys have a geometry teacher that probably wants you to do the same thing. So that's square root of 12. If we break down square root of 12, it becomes 2, 6, 2, 3. 1, 2 leaves the house. A 3 has to stay home alone. So we get 2 radical 3 equals our height. We know our radius is 2, so we're going to do square that times 2 radical 3 and divide by 3. We get pi times 4 times 2 times radical 3 over 3. We end up getting 8 pi radical 3. Move this over down here. Divided by 3 inches cubed. And that is our answer. Hope you guys found this helpful. Volumes of pyramids and cones actually aren't that bad. It's more of a matter of finding the proper measurements first, which you have to use some other principles of geometry like Pythagorean theorem, maybe some trig. But other than that, should be good. Hope to see you next time on West Explains Best. Have a nice day.